So in this video I want to talk to you about finding the y-intercept of a quadratic curve. Now, when we were doing this with linear graphs, so straight line graphs, if you have y equals 2x plus 3, for example, then you should be able to identify where that's going to cross the y-axis. When an equation is written like this, it's quite clear as to what that value is. So in this case, that would be 3. So I know that this is going to be a line with positive gradient going through 3 on the y-axis. That's the y-intercept. If it was y equals 5 take away 6x, then it's not in the form y equals mx plus c, but I should still be able to identify where it's crossing the y-axis, because remember, you could just reorder those two terms. This is minus 6x plus 5, and so here you can see that m, the gradient of the line, is minus 6, the intercept is 5, and that's really what I was looking for. So it's going through 5 on the y-axis. We've got a negative gradient, so it's going to go down that way, and so that's 5. Okay? If, however, it wasn't in that form at all, so let's say we had something like 3x plus 2y is equal to 12, where does that cross the y-axis? Well, if that was the only question, if the question was determine where this crosses the y-axis, there are two avenues open to you. The first one, and the longer one really, is to rearrange this into y equals mx plus c. Okay? So let's say we did that. Let's rewrite it here. Give ourselves a little bit of space. Okay? Right. So if I was to rearrange this into y equals mx plus c form, I could subtract the 3x from both sides. Now I know that in the playlist we haven't done any real rearranging yet, but I'm just kind of, if you have done some of that before, then maybe you'll be able to follow this through. And then I could divide through by 2. So 12 divided by 2 is 6. And then we have minus 3 divided by 2. Let's just leave it as a fraction. We've got this. So here, if you wanted it the other way round, of course, just like we did in the previous example, you could reorder that minus 3 halves x plus 6. And so the y-intercept here is 6. Gradient is minus 3 halves. So I could go about it that way. But there is another way. So the first thing is to remember what the equation of the x-axis is. So what is the equation of the x-axis? It's not just the x-axis, it actually has an equation for that line. So this point here, for example, is 0, 0. Here's 1, 0. Here is minus 1, 0. Here is minus 2, 0. Okay, and you can see as you travel along all of these points along the x-axis that what they have in common is that all of the y's are 0, all of the y coordinates are 0. And so this has the equation y equals 0. Okay, if you do the same for the y-axis, then here is 0, 1, here is 0, 2, here is 0, minus 1, and so the x-axis, or sorry, the y-axis rather, is x equals 0, because all of the coordinates along that line have x coordinate 0. So you get this strange picture. Just erase that and I'll redraw it. You get this strange picture where the x-axis is y0 and the y-axis is x is 0. It feels kind of a little bit strange writing it that way round, but that is the case. Okay, these are the equations of those lines. So if you wanted to work out where this line crosses this line, well, that is when x is 0. So if you made x to be 0, it is essentially like covering up that term, because you'd have 3 times 0, which is 0, and then you would have 2y equals 12. So y would be equal to 6. Okay, so we actually know that that point would be 6. If you want to know where it crossed that line, then you put y as 0. Cover up 2y. We have 3x equals 12, so x must be equal to 4. And then you have your line that's going through those 2 points. So you might be thinking, well, I'm sure this video was about quadratics, right? But this is really to set the scene, because these skills still work for quadratics and all the other graphs that you can meet while studying maths. Okay, so if you decide to go on to study A-level maths, you'll look at lots more graphs and functions, and they play by the same rules. If you want to know where it crosses the x-axis, you put y as 0. If you want to know where it crosses the y-axis, you put x as 0. And that is always the case. So, let's say I have y equals x squared plus 4x take away 7. And I wanted to know, where does this curve cross the y-axis? Okay, well, just as we did before, in order for it to cross the y-axis, x must be 0. So what's going to happen when x is 0? Well, you can have 0 squared, which is 0, 4 times 0, which is 0, and so y must be equal to minus 7. So what you end up with is saying, well, this here is your y-intercept. This is where it's crossing the y-axis. So for this one in particular, if you're wanting to know kind of like what it looks like, you would have plus 2. So it looks something like this, going through minus 7 on the y-axis, and that's its y-intercept. Okay? So, is that true in general? Can you just look at the final term? Is it just like when you've got it in y equals mx plus c form? Okay, remember this for a straight line equation. This is your y-intercept. Is it the same? Well, if we've got y equals ax squared plus bx plus c, so this allows for any b, any a, any b, any c you want. If x is 0, then this term is 0, and this term is 0, and you get y equals c. So, this is your y-intercept for a parabola. So this allows you to go, right, here is the quadratic. I've got this number on the end. When x is 0, y is going to be that. So that means that's where it crosses the y-axis. So we can read that off quickly and easily.